When determining the pitch and loudness of a sound, it is vital to use the measure of frequency. It helps determine how aged or old your ears are. Typically, older people's range of frequency tends to be smaller than younger people. This first demonstration will detect how good your ears are. When you play the video, sounds begin and you pause the video as soon as you hear that sound. Then it determines how good your hearing is on a scale. Inside the temporal lobe is something called the auditory cortex. It is specialized for hearing different sounds and interpreting them. It also helps people understand what sound something is. So when you hear a noise, like a screeching high noise, you're gonna press the space bar as soon as you hear it, okay? So I'm gonna start it right now. Press the space bar as soon as you hear it. Okay. So his results ended up being superhuman. So he had 18,791 Hz for frequency. I'm gonna try again. I'm gonna turn the sound down. When you hear that again, press the space bar. He was also superhuman. It was a little lower because the sound was down. I'm gonna try again with the sound down even more. Press the space bar when you hear it. And that one was a little lower too.
Starting in 5, 4, 3, 2, 1.
The next activity is a test to tell you how you interpret different sounds. When you hear an animal noise, you sometimes can't figure it out until you're given options. This test will detect if you know the animal right away, after you are given options, or after the animal is revealed. To be able to hear these sounds, the sounds transfer into the ear canal, which then causes your eardrum to move, creating the vibration of the sound for your brain to register it. The vibrations are almost like waves in the ocean. They travel through and are interpreted into a certain sound. Then the nerves signal to the brain what thing or item that sound is, such as an animal. When you hear the animal sound, you need to try to guess it and say it out loud, and then it'll give you 3 options, and then pick one from those, and then it'll tell you the answer. So just tell me what the animal sound is that you hear.
A tiger. Actually, that's a walrus. Never mind.
So he just got his options, and he picked walrus instead of tiger.
Camel.
Okay.
Sounds like a pig. Yeah.
What?
I think it's a pig.
Now guess the next one before the options come up. So right now.
Some kind of frog. Or toad.
Options came up and there was a frog on there. And we'll do one more. Bunny? Yeah. The last demonstration is detecting if you can hear the melody in a set of notes. The left hemisphere is where you are able to hear melodies and different sounds. Broca's area processes speech. This test will play a verse in which there is a melody included. It will determine if you can hear the melody or not. Only about 1 out of every 20 people can actually hear the melody part. The ones who didn't hear it cannot be sure if there was an actual melody. To hear the melody, you need to change your brain's focus point. The hearing on the right side processes overtones, which means it's the side that will detect those little melody sounds. When I play the video, listen closely for a melody. It is typically the higher part of the verse.
Syllables. So I'm singing only one tone, but there is a melody hidden. It's from German classics, and you probably know it. De l'ave que t'aime de la vaque la Genève c'est elle des bègues le valable Genève.
Overall, we measure hearing with our temporal lobes in our Broca's area. These demonstrations can help us and doctors determine how well someone can hear. If they do not do well on the frequency test, it means that they don't have very good hearing. There are different levels of frequency, and they range from bats to dogs or just like a stone. That means that if you can hear up to 20,000 hertz, which is the measure of frequency, then you are able to hear just like a bat. If you cannot hear anything until around 20 hertz, then you are just like a stone and hearing a noise, and you should probably go to the doctor. Eli ended up having superhuman hearing. He is young, so his ears are still working perfectly, so that makes sense. The second activity helped Isaiah determine which animal makes which noise. He stumbled on a few, but once he got the chance to see 3 different options, he could listen again and figure out which animal it was. In the last activity, we could detect if we were 1 out of every 20 that could hear the melody of the verse based on our left and right hemispheres. There are many different causes of hearing loss, but one of them would be aging. As you get older and your ears get worse, your brain cannot detect certain sounds as quickly as if you were a teenager like Eli. Another cause of hearing loss could be genetics. It could be a factor of family genes that your ears aren't the greatest. Other causes of hearing loss could be from an illness or some sort of injury. Even a stroke can cause hearing loss. In conclusion, when we determine different sounds, our brains are working hard to detect what that sound is, or when we can hear it.